Good afternoon, distinguished colleagues and guests. It's May 13th, year 2022, 2 p.m. Moscow time. And we're beginning the panel session for the defense of the thesis by Alexander Kononov. The thesis is submitted for the academic degree of Candidate of Sciences in Chemistry. The specialization is 142, Analytical Chemistry. The topic of the thesis is the development of a method for lung cancer diagnosis based on online analysis of exhaled breath using metal oxide gas sensitive sensors. Under the order issued by the Academic Secretary of St. Petersburg State University, Alexander Gnatov, as of February 21st, 2022, number 1380/1, I, Lyudmila Kartsova, Doctor of Sciences in Chemistry, Professor of the Department of Organic Chemistry of St. Petersburg State University, was appointed the chairwoman of the board. They would also approve the members of the board, namely Oleg Radinkov, Doctor of Sciences in Chemistry, Professor of the Department of Analytical Chemistry of St. Petersburg State University, Valentin Semyonov, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Analytical Chemistry of St. Petersburg State University. The following members of the board are working remotely today: Alexei Shapashnik, Doctor of Sciences in Chemistry, Professor, Head of the Chemistry Department at the Peter the Great Voronezh State Agrarian University. Alexei, do you hear and see us? Yes, I do. Wonderful. And Larisa Lvova, Doctor of Sciences in Chemistry, Associate Professor at the Department of Chemistry and Technology at Tor Vergata University of Rome. Larisa, do you see and hear us? Yes, both. Great. And our candidate for the degree is Alexander Kononov. We also have the thesis supervisor at the defense, and that is Doctor of Sciences in Physics and Mathematics, Professor, leading researcher at the Department of Analytical Chemistry of St. Petersburg State University, Alexander Ganeev. And in order to improve the quality of connection, distinguished colleagues who are working remotely, I kindly ask you to switch off your microphones, but don't forget to turn them on when I give you the floor. And I would also like to inform you that the panel session of the Dissertation Board is being recorded and broadcast on the St. Petersburg State University website, and it is also interpreted from Russian into English, or vice versa, in case it's needed. And currently we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions to Mr. Kononov online, the questions regarding the thesis or the scientific discussion. So thus, our listeners can participate in the scientific discussion. These questions will be forwarded to me by our technical service, and I will read them out during the discussion. And the questions must be directly related to the presentation and content of the thesis. And don't forget to give your name and position of work at work if you submit a question. Those questions that have nothing to do with the scientific discussion or the dissertation text and the overall assessment, and also anonymous questions, will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by the local regulatory acts. The session of the dissertation board is valid, providing 2/3 of the appointed board members are present. And the total number is not to be fewer than 4 people. Our dissertation board consists of 5 people, and everyone is with us today, including 2 members of the board who joined us remotely, and we have a multimedia connection with them. Therefore, we have the quorum. And I kindly ask the member of the Department of Dissertation Board Support, the curator of the defense, to fill out the attendance list. Our agenda for today is as follows. This session will approximately take 2 hours. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. Replies to questions, if any, 5 minutes. Second, the candidate's presentation providing an overview and findings of the research. 15 minutes will be given for that. And third, questions to the candidate regarding the presentation. Fourth, the candidate's replies to the questions. 5 minutes for all the questions. Then external reports on the thesis, if any. Then the reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions. 10 minutes to each board member. Then the chairman will deliver the report on the thesis, also 10 minutes for that. Then the candidate's comments about the report on the thesis and replies to the questions, and 20 minutes for that, followed by open discussion, speeches by those present at the defense with a brief presentation of the positions or questions or suggestions to the candidate for the degree on the topic of the research. 2 minutes each. And at that, I kindly ask you to fill out the registration list and don't forget to give your full name, academic rank, position, and place of work before I give you the floor. Then the chairman will ask the questions submitted during the broadcast via our website. I would like to draw attention to the following fact. Written questions that will take more than 2 minutes to read out will not be voiced. Then the candidate's replies to the questions, followed by the presentation of the candidate's thesis supervisor. 3 minutes will be given for that. Then a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of the results is not broadcast. After that, we're going to organize open balloting. We're going to count the votes and record the results in the protocol. Afterwards, we're going to make a decision on whether to confer the academic degree or not. And finally, we'll give the floor to the candidate for the degree for the closing speech. Distinguished colleagues, are there any questions or objections? None? No. Okay. Okay, no one. As there are no objections, I switch to the next item in our agenda. And first of all, I would like to ask you to kindly switch off the sound on your mobile phones. And those colleagues who are working remotely today, I kindly ask you not to switch off your phones so that we could get in touch with you as quickly as possible if we have some technical break. And thank you very much for understanding. So I therefore start. A thesis by Alexander Kononov for the academic degree of Candidate of Sciences in Chemistry, specialization 142. Analytical chemistry, is titled The Development of a Method for Lung Cancer Diagnosis based on online analysis of exhaled breath using metal oxide gas-sensitive sensors. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University, issued February 2nd, the year 2022, number 658/1. Alexander Kononov has prepared his thesis at St. Petersburg State University as a postgraduate student, and his thesis supervisor is Doctor of Sciences in Physics and Mathematics, professor, leading researcher at the Department of Analytical Chemistry of St. Petersburg State University, Alexander Ganiev. 3 published works describe the research findings. And all these articles are published in journals indexed in Web of Science and Scopus. And there are no publications in peer-reviewed journals recommended by the Ministry of Science of the Russian Federation. All the documents submitted by the candidate for the degree, as far as I'm informed, comply with the requirements of St. Petersburg State University and are found in the certification file of the candidate for the degree. And curator of the defense, the member of the Department of Dissertation Board Support, has all the copies of these documents. And before I give the floor to the candidate for the degree, I would like to ask a question to the members of the board, distinguished members of the board. Do you have any general questions to the candidate for the degree? Is there a need to consider the whole list of documents submitted for the defense? No need for that. Okay. No questions? No questions, and we are ready to start. I would like to remind you that you can answer all the questions in reviews after your report. You can answer either at once or after each review, so we'll discuss it later. So, Alexander, please, you have the floor. Thank you so much. Distinguished members of the board, distinguished guests. The topic of my report is the development of a method for lung cancer diagnosis based on online analysis of exhaled breath using metal oxide gas sensitive. Lung cancer is a well-known disease, and early detection leads to the improvement of a result. But current early diagnosis methods are not as efficient as we need, and this leads to detection at later stages, and therefore we need to develop early diagnosis methods, and we should be able to use them in early screening, and that's an important goal that we need to achieve as soon as possible. The analysis of exhaled air to detect biomarkers, cancer markers, is a popular field, and VOCs are formed during the exchange reactions, and in pathological states we have the shifts in metabolism that lead to the change in profile of exhaled air. And such changes can be detected with further diagnosis. And current analysis methods can be divided into two groups: methods with quantitative distribution detection and methods that detect profiles. And these diagnosis methods should have a short sampling time. It should be non-invasive, cheap, and it should work online. Therefore, it's easier to address the second type group and to use multi-sensor system based on a range of typical sensors. The most popular choice here is gas-sensitive semiconductor sensors. And for this type, we can detect a range of advantages in the context of the development of diagnosis methods. That they are cost-efficient, they are stable, they have short response time, and they are sensitive to a broad range of compounds. And as for the disadvantage, that's variability during production, and current technologies do not allow us to get sensors with identical characteristics. Therefore, they don't ensure the general response, and this prevents large-scale use of multi-sensor systems, and this does not allow us to use one forecast model for all the devices. The Excel graph contains hundreds of compounds, but just several of them can be useful for us. And here you see the potential biomarkers of lung cancer, and they are informative. And they were found informative in no less than 2 literature sources. One compound is not enough to divide healthy from the sick. Therefore, in order to stay efficient, we need to analyze a set of compounds that can create the profile. And the principle of work is based on the change of electric conductivity. The absorption of gases depends on the temperature of the layer. Most frequently, as material for sensitive layer, we use nanocrystalline oxides of stannum, zinc, and vanadium. And they are semiconductors with n-type conductivity. And we see a huge absorption here. And this is explained by free electrons in conductivity zone and oxygen vacancies. And the work of sensors happen in oxygen environment, and here as reduction agents, we use a specified agent that leads to the depletion of the surface and an absorption of reduction gases, and here we can use some VOCs. We see the number of electrons that is growing on the surface, and gas sensitivity conductivity increases. And in order to assess the quality of the diagnosis test, we need information on the presence of the disease. We can use both the test, and also we should use some standard method as well. And using this sample, we can classify the outcome as true, positive and negative, and false positive and negative result. And here we see the matrix of mistakes. And we use it to calculate diagnostic indicators, sensitivity, specificity, accuracy, and additional ones as well. On this slide, you see the table with diagnostic matrix for works where we used metal oxide sensors in the range. The most important requirement to the potential diagnosis methods is high level of specificity. These indicators should be no less than 99%. Otherwise, we see a growth of unjustified medical interventions and the cost of analysis as well as time. And as for sensitivity, it should be no less than 90%. And the results demonstrate rather good potential of metal oxide sensors in the development of diagnostic method for lung cancer. But this table can give us just several works that are close to the required. And we also need to ensure cross-sensitivity of sensors taken for the analysis. Thus, the goal was to develop a methodology of online analysis of exhaled air using gas-sensitive metal oxide sensors. And the problems were as follows. We needed to develop the scheme of online analysis without preliminary sampling, then detection of relative sensitivities of the sensors, comparative medical research and analysis of exhaled air, and also the choice of efficient data processing algorithm that allows us to separate the sick from the poor. And also we needed to conduct studies on standardization of two multi-sensor systems. In this work, we used multi-sensor systems that consist of 3 sets. Each set consists of 6 multi-sensitive sensors produced by Zaltgel method at Kurchatov Institute. Each sensor is a multi-layer system that consists of a ceramic layer, heated layer based on platinum, and gas-sensitive layer that has titanium oxide nanoparticles with different additives. And in order to ensure more informative characteristics, we conducted tests at different temperature regimes. And in this table, you see the calculations for sensors of multi-sensor system 1 for regimes T1, T2, and T3 accordingly. On this slide, you see the final analysis scheme used for both real samples and for test samples. And in this work, we also chose direct online analysis. And in order to eliminate the memory effect associated with absorption of VOCs in transportation tubes, we installed a pump for continuous blowout of the tubes with increased speed of 3.5 liters a minute. And this allowed us to avoid drift. And in order to take into account exogenic VOCs, we also used ambient air blowout. And we've taken the integral of conductivity, took out the basic line space, and we also used polyvinyl fluoride packages in order to assess the sensitivity using biomarkers and you see the biomarkers that we used. And as for the concentrations, they were 0.5 to 500 ppm that work quite well, and the parameters are given here on the slide based on coefficients of tilt. We calculated the relative sensitivity coefficients for propanol 1, and here you see that relative sensitivity of the chosen sensors can differ by several orders, and it demonstrates good cross-sensitivity of the set. All the studies with patients were conducted with at Peterhof Institute, and we installed multi-sensor system 1 there, and we analyzed the samples of 118 patients that satisfied that met our criteria. There were 53 healthy patients and 65 patients with lung cancer. They signed informed consent. And as for the cancer patients, they had a morphological confirmation of their analysis. And as for healthy controls, those were people without any clinical symptoms. On this slide, you see the analysis scheme that we used in the pilot study. The parameters were as follows: 10 seconds of sampling, then the speed, 3.5 liters per minute, and integration period, 90 seconds. Patients were informed about the need to abstain from smoking and eating for 60 minutes before the study. Then the patient rinsed mouth with warm water and waited for 10 minutes before the first test. The relative humidity was 60%. And here you see the scheme of processing and data analysis that we obtained for the samples at multi-system set 1. So here you see the basic block of scheme where we assessed the mean diagnostic metric value and 15 different breakdowns for the tests. As a classifier, we used K-nearest neighbor classifier, random forest model, and a model of single-factor standardization. So here you see the parameters for each classifier. During cross-examination, we've chosen the such a combination that allowed the matrix to be maximum. The initial set of data, you see this matrix is 118 by 18, and vector of true marks 118 by 1. 0 is control group, 1 is patient with lung cancer. And in two-dimensional space, we constructed two matrices for the temperature regimes. And here you see this truncated matrix for the first temperature regime for S1, S4 sensors. And you see that most division was observed for sensor 4 in the first temperature regime. The key component, principal component analysis was used as well. Here you see the distribution between the cumulative share, and that was 85.6%. And on this slide, you see the samples divided into classes, and it should be mentioned that the attempt to use PCA method to reduce dimensionality did not bring us some significant improvement. And now let us shift to the process of analysis. According to the analysis scheme for each classification and for each set of data, we got a probability vector. And in order to shift to binary result, we used standard classification threshold of 0.5. Then we calculated outcomes for every classifier. We constructed the matrix of error. And similarly, we used matrices for test data. Then we calculated diagnostic indicators, and then we averaged them on each iteration. And simultaneously, from a probability vector, we constructed ROC curves. And here you see one iteration example. ROC curve represents different combinations of specificities and sensitivities, and as a quantitative characteristic, we use the area under the ROC curve. And on this slide, you see the final results of the calculation of diagnostic matrix for every algorithm, depending on the set of data that we've used initially. And it should be mentioned that during transition from training to test, we had certain drop in the quality of classification, but it was not critical, and it still allowed us to find one model with applicable results. Therefore, to choose optimal classifier, we use the results obtained on test sets based on the previously mentioned requirements on to sensitivity and specificity. We use the K nearest neighbor classifier. The results demonstrate the opportunity to introduce this multi-sensor system into practice, and the major matrix values are given here, and they can be taken into account during testing, and they are highest compared to others. And the implementation of this regime allows us to avoid additional sampling preparation stages that could have a negative impact due to low VOC contamination, for example. And this method takes just 25 minutes. The pumping speed allows us to minimize the memory effect. And this test is also quite good for the time of the test, and it's convenient for the patients. Part of classifiers can be used to assess the importance of characteristics and the importance of characteristic can be assessed using logistical regression, and this approach can be used further on to conduct optimization in order to resolve the problem with instrument variation of sensors. We use gradation dependency transfer methods. And this approach is based on the fact that we need to transform the data from additional multi-sensor system in accordance to the main multi-sensor system. So we measure both sets, and then we use regression algorithms to establish connection between them and dependency. And we've found out two model goals. First of all, we need to assess the efficiency of the classification of single component model gas mixtures of VOCs using classification model of system 2.1, and similar goal was achieved for multi-component mixtures. On this slide you see the analysis scheme that we used in the experiment. The parameters were as follows. You see the speed of flow 0.4 liters per minute, sampling time 90 seconds, and integration time 300 seconds. And here you see the processing scheme on standardization of two systems. A standardization method, we use a single factor standardization with and without free coefficients, direct standardization with the use of regression for lateral structures of type 2, and an option without corrections. And as a classification model, we used multi-class method of support vectors of Kromesinger and standard method of support vectors. So we assess the accuracy for different options. Here the options when the model of classification and the test sample belong to one system, and also had an option when the trained model of multi-sensor system 2.1 was used on test set of 2.2 without corrections, and similar options with standardization. And also here you see the table with a set of hyperparameters for each classifies an optimal parameter with as for the optimized metric, we use the accuracy of classification. And for the first problem, we prepared gradation gas mixtures for 3 compounds, and we had 2 samples for every concentration, and therefore we had 42 samples here. On this slide, you see the histogram of accuracy on test sets of data, depending on the range of samples. And here we studied here we had an interval from 2 to 11. And what can be seen from the graph when using ordinary model, you see this blue and yellow lines, we get accuracy of 1. And this becomes a goal for us that we need to achieve using different multi-sensor systems for the test set and for the classification set. Without the correction of response, when we use this model of when we use the model of system 2.1 on the test set of 2.2, this level is our goal here, and single factor standardization allows us to achieve the level of 4. And when we talk about multi-component mixtures, we prepared gas mixtures that were divided by components, and we had 16 samples here. On this slide, you see the similar scheme of results, and here the accuracy of classification is given for all options depending on the number of samples. Here the interval was from 2.7, and when we use one source for data model and for test sample, we get accuracy of 1. And when we use model of classification from MS 2.1 and test set 2.2, we get drop of accuracy up until 0.5 without the correction of response. And when we use correction, we achieve our goal. And the minimal set of samples was 4. And we use 3 methods here. We use direct standardization with regression here. For visual interpretation of these results, we use the method of principal component analysis. So this PCA model was constructed. It is given in the results are given in blue. We also used samples of system 2.2 without correction and with correction using single factor standardization. Here you see this dots in blue. Without correction, it is hard to differentiate the samples of compounds into pluses and stars. But when we add correction, it is done quite easily. So the results demonstrate the opportunity to conduct standardization of response in one multi-sensor system. Single factor standardization demonstrate good accuracy at minimal set of samples, that namely 4 of them. And here are the conclusions. Thank you, Alexander. And I would like to ask the members of the dissertation board, do you have any questions to the candidate for the degree? So, please, Valentin. I had the following question. The most so because in your title you talk not just about the development of method, but about the use of metal oxide gas-sensitive sensors. What was your role? What was your participation in the development of sensors? Did you take ready-made sensors for your multi-sensor system? Yes, thank you very much. As for my direct participation on the use of sensors, we've taken ready-made sensors. So it was not my goal to develop the material for sensors, so we've taken ready-made sensors and selected them for multi-sensor system. So you conducted the test of characteristics of sensors, or they gave you the ready-made characteristics. These characteristics were obtained by me. For sensors? No, those that are given on the slide. As for gradation dependencies and relative sensitivity, so these results were obtained by me. Okay, thank you. Thank you. Other questions? Oleg? I have a general question. In your thesis, in your literature review, you give us an idea that for one component, you cannot differentiate the sick from the healthy. Why? Is the accuracy too low, or do you lack sensitivity for detection? Or is it associated with some random characteristics? For example, in one patient, the concentration may be lower than in healthy person, and another patient may have the concentration higher than in healthy person. So you had 6 sensors, and you could trace the indicators. So that's what makes it interesting. I know that in your archive cloud you have all these results presented, but I did not manage to analyze them. Yeah. As for the fact that one compound is not enough, well, in breath we have hundreds of compounds, maybe more than 1,000 compounds in a single breath. Therefore, during the analysis of literature sources, we've detected that in comparison of different studies, indeed in one study, the concentrations, or the mean values of concentrations for some analytes for the healthy, they were higher, and in some works I saw contradicting results, and this is associated with different methods that they used for sampling preparation. So these situations may happen, and it's probable that during disease progression we see the change of concentrations for certain compounds. So there's a list of compounds that form an impact on the disease progression. Well, I did not hear the answer. I'm not interested in literature data. I'm interested in the data that you obtained when you analyze signals from different sensors. For example, the sensor gives you that for one patient, some result that for some patients results differ. Yes, we had such cases. Yes, I've shown it on the truncated matrix, on the scattering graph. We can assess it on diagonal graphs. The distribution of responses that we get during integration can be compared on the graphs. For example, for sensor 4, in healthy people, the distribution shifted to the right. Aleka is satisfied with the answer. Well, I understand that he answered to the best of his ability. Yes, Larissa, any questions from you? Yes, I also wanted to ask a question associated with the previous question. So you worked with ready-made sensors. The number of these sensors in the set of sensors was also defined. So was it given to you as an initial data? Was it given to you initially, or you somehow reduced the number? I don't think that you may have increased the number of sensors, but maybe you reduced them during study. That's the first question. And the second question, on one slide you showed it that your sensors were based on standard oxide with different additives. Maybe that's more of a comment rather than a question. And it would be useful to write what kind of additives did you have. Okay, is the question clear? Yeah, thank you. As for the number of sensors in the multi-sensor system, I had certain sensors from different sensor materials, and I tested them based on the literature review. I considered how many sensors are used in these works. So I just wanted to consider whether I need to increase the number of sensors in order to improve the quality of information. And basically, the literature sources say that mostly the number of sensors was 10, because otherwise there are some interruptions and interferences. And when we tested and chose sensors for the first multi-sensor system, we've chosen the stability of signal, the rapid response time, And also we were based on the relative sensitivity and test classification of different VOCs that we tested above the ones that were mentioned in the work. These were the 4 criteria that we used, and 3 different sensor materials worked best, and out of them we added up coupled sensors in order to obtain best results. So we thus differentiated the sensors, and initially in the multi-sensor system we had 7 sensors, though in my work during use I've just taken away 1 sensor because it was less informative and it allowed me to optimize the set of sensors. Larissa, are you satisfied with the answer? Yes, thank you. It became clearer. And by the way, you answered the previous question as well. Alexei, questions? Yes, first of all, I would like to ask Alexander to answer the questions louder, because I heard him better when he delivered his presentation. I wanted to ask the following question. This reference group of healthy controls that participated, was it chosen randomly, or did you have some principles to establish it, to choose these people? So please be louder. Yes, sure. This group was chosen at the Peterhof Center. So initially we conducted the breath samples, and after that people were diagnosed. So the group was randomly chosen. Thank you. Thank you. No other questions? Yes? None? Okay, I have the following question. So you mentioned online analysis without concentration. Maybe you'll use some analytes, maybe minor, but still, maybe they are diagnostically important. This online analysis without concentrations. If they can be detected with metal oxide sensors, then it does not have an impact. Okay, thank you. Now let us shift to the next item in our agenda. These are the speeches of the members of the board with their reviews and assessment of the study. I would like to remind you that you can answer questions in each review at once after the review, or you can answer all the questions at once after the last review is read. But I offer to answer after every review, answer the questions after every review. Okay. Now I would like to give the floor to Professor Rydenkov. I would like to remind you at once that all the reviews were already published on the website of St. Petersburg State University. And considering that, I offered to give you just the key points, the criticisms, the questions. Yeah, no objections about that. Okay, let us continue. So please, Oleg, you have the floor. Distinguished colleagues, I wanted to share my impressions with you on this thesis. As other members of the board, I've given a positive feedback on this thesis, and the presentation just made me sure that I had the correct assessment. So I'll be pretty brief. And I wanted to remind us that the work is dedicated to early diagnosis of lung cancer, and its relevance is not questioned at all, as far as I'm concerned. And it is of key importance that this problem is resolved using express non-invasive method based on the analysis of exhaled air and quite naturally it is the work in the analytical chemistry field as we see it at our university. And as for the complexity of choice for this analysis, on the one hand it is explained by lack of standardized methods, and on the other hand by very strict requirements to these methods. And from a multitude of solutions, Alexander chose multi-sensor system in combination with lack of preliminary sampling, and the results demonstrated that this choice was correct. And as elements of multi-sensor system, he offered metal oxide sensors that are gas sensitive, and accordingly their low selectiveness that was mentioned by the author is compensated by high productivity, high speed, lack of memory effect, possibility of cleanup, and that is of paramount importance when we conduct mass analysis in online regime. And I believe that in this presentation, this massive character should have been reflected. I believe you did not mention that in your report, that it is a cost-efficient, it is a mass flow methodology. And one of key problems in the analysis of air that you managed to cope with is a negative impact of the content of air on the results of diagnosis. And that was the problem that was resolved quite easily by preliminary blow-up of the system. And also the patient should have stayed for several minutes in the lab before the start of sampling. This work is highly credible because, unlike many other works, similar works, here the author used standard gas mixtures at the level of concentrations with nomenclature that complies with the concentrations in sick and in healthy controls. And now I shift to the conclusion. But before I conclude, I just wanted to mention the drawbacks, and to avoid misunderstanding, I should also read them from my work. The first point: the work lacks sufficient substantiation of the choice of materials to create to develop sensors. You mentioned platinum and palladium, and sensors S1 and 2, they were additionally doped with cadmium, and S5 and S6 were doped with lanthan. And why did you introduce additional dopants? And what was their content in the sensor? So I had 5 questions, and fifth does not require an answer. Then, why did you differentiate the number and the content of gas-sensitive sensors? And there's as well as nomenclature of test substances in the thesis and in articles where you have described the major results of the work. Because I've read an article in the Questions of Oncology journal, and they use 7 sensors without additional dopants. And as test substances, you use the propanol, ethanol, and ammonia. And in the thesis, you use 6 sensors, and as test sensors, you use propanol, heptane, and aromatic hydrocarbons. Third question. Oh, it's not rather question, but rather criticism. Use the static way of acquisition of gas mixtures, and this method is quite labor intensive, and it is not recommended due to absorption on the vessel wall. And most efficient method here is a dynamic method. You see, in Russia, we produce vapor phase sources of gas mixtures, and this results in volume of generated gas mixture for one source. It gives us 1 cubic meter, and the concentration is from 0.1 to 1,000 ppm. The fourth remark. So I did not like the resolution for the problem of the impact of humidity on the sensors data. So you've chosen 60 plus minus 5% humidity. As exhaled breath is saturated with steam, the zero ambient air that you use for the blowout, it should have the humidity close to 100%, and you should not introduce this steam to all the room, but it is enough to saturate just the air that you use in the blowout procedure. And fifth comment is about different dimensionality that you should have used in Formula 22. So these criticisms do not reduce the overall high quality as I see. Do I need to read the conclusion? Yeah. In this case, yeah. The thesis by Alexander Kononov meets the requirements of the order is on the procedure of granting academic degrees at St. Petersburg State University. And I believe that Mr. Kononov deserves the academic degree of Candidate of Sciences in Chemistry and Analytical Chemistry. Thank you, Oleg. So, Alexander, are you ready to answer? Yes. Yes, I am. Okay, please. Oleg Vasilievich, thank you very much for your remarks.
Да, это верное предложение. На экран можно вывести вопросы, если у вас есть. Это отличит наше восприятие.
Yes, unfortunately, I don't have the questions on the slide, therefore. Okay, you can answer straight away. Yes, as for the specification of the choice of sensors, we've chosen sensors that were produced by our Moscow colleagues. So that was Kurchatov Institute. And from this set, according to the stability of the signal and according to the quick feedback and according to the ability to differentiate organic compounds, we've chosen 3 sensors based on this criteria. And also we added sensors with different resistance of the heater, so that they would have different temperatures to get different relative sensitivity. Thus, we create 6 different sensors. Then, as for the dopants, They were introduced to get different response to the analyte, thus improving the relative sensitivity of the set of sensors. Dopants are introduced in order to change the structure of nanocrystals, and this influences the number of vacancies, and it influences the response signal during the interaction of analyte with the surface. Is that it? Yes, for the first question. Okay, then. Oleg, maybe I should answer it once. Well, I just wanted to hear not the general answer, but rather a specific one. So why did you introduce cadmium? Yes, as for the elements that I mentioned in my work, cadmium was a misprint, unfortunately. Yes, unfortunately. So there was no cadmium there. And what did you have there? Well, these sensors did not differ in quality content. Unfortunately, I don't have access to the set of additives, therefore I didn't give them here. So you didn't choose the additives? No, I didn't choose them. Okay, but what can you presume? If you didn't choose these additives, how do you think this lanthanum should it improve the selectiveness to what substances, to what reactions? Well, for S5 and S6, we had high sensitivity to propanol, or to spirit. Okay, you can continue. There were other questions as well. Yes, and please louder. So the second comment, the data in the article and in the work is based on one research, and as for the questions of oncology, I did not give the details on the sensors. I just used 7 of them, and in this work and in my article, experimental article, I've given 6 sensors because the 7th was taken out of calculations because it had low information capacity, and when I excluded this data, the quality of classification did not drop, and it was done to optimize further set of sensors. Then next question on compounds. Initially, to study the opportunities of multi-sensor systems, as was tests, we analyzed different compounds, those given in this work, like propanol, anheptane, ethylbenzene, oxylene, and acetone, ethanol, and ammonia, and so on. In literature sources, we also have an additional possible marker, and we had radiation dependencies for all these compounds, so we were free to choose what compounds to give as test substances. And as for questions of oncology, there we demonstrated the opportunities of this multi-sensor system in diagnosis of other diseases, because ammonia is found in lung cancer cases, and it can be a possible biomarker for different diseases of liver and kidney. Okay, you can answer. Other questions as well? Okay, third question about vapor phase source of gas mixtures. Well, the thing is that the method of mixtures preparation was quite cost efficient, the one that we've chosen, and it was more flexible, therefore we've chosen it. And as for the sorption on packages that we used, it was quite negligible, as it was demonstrated. It was observed for certain cases, but that's a long-term story. The preparation of the analysis took us just 4 hours. Done. Next question. About humidity of the surrounding air. Once again, thank you very much for this advice. In this case, we used relative humidity, and we wanted to reduce the fluctuation of the input of vapor into the analytical signal. Yes, certainly water is included into the signal. We have certain share of it, but still this option was simple and it did not require any costs. And if we wanted to ensure the humidity of close to 100%, we would need additional equipment, and this increases the risk of additional condensation, and we would need additional equipment to avoid this risk in this case. Next question on universal gas constant in the formula. Well, it should be given in kilopascal per liter, divided by mole, multiplied by Kelvin. So that's it, yes? Yes, there were additional comments as well. Well, no need for that, these are just misprints. Yes, that's okay. Okay, Oleg, are you satisfied with the answers? Yes, basically, yes. I just wanted to wish you to use vapor phase systems, because you use static method in a dynamic system, so it's better to use dynamic approach as well. Two dynamic systems, they combine best. But that's just a wish. Okay, thank you so much. Professor Simonov, now your assessment. And I would like to ask Alexander to ask quickly, accurately, and loudly. Okay. Okay, thank you so much. I wanted to mention at once that certainly based on the presentation and on the text of the thesis and the analysis, this work is pretty relevant, and its practical value is not questioned at all. But what's most interesting here, and that's, by the way, characteristic for our department, you continue the work on multi-sensor systems. And these systems like ENOS was targeted on a very specific problem of lung cancer early diagnosis. So, such goals are really great. And, I had a question of heredity. What did you take from the previous works on the ENOS that were developed on radiochemistry department in the of Vlasov, but that's, a thing of the past. And certainly you could not but use chemometric methods. That's very important. And you found your niche. As for scientific novelty, it's not questioned as well for this topic. We not only talk about the practical value, the novelty is quite obvious. And now I'd like to shift to the questions. Certainly, they are more of chemometric character. So I have the following questions. If you answer them, I believe we will all understand the goals of your work better. Why, to process the sensor signal, you've chosen the conductivity integral in time, excluding the area formed by the basic line. So that's for text on pages 51, 52. Second question, what goal of constructing rock curves and calculation of areas below them. So what's the goal here? How can you use this calculated matrix? That's page 70. And why of all the gradation dependency transfer options you've chosen the approach on standardization of response? And these are the questions that I wanted to ask. And finally, I wanted to say that the criticisms do not influence the overall high quality of work, because that's a very successful study. And at once I wanted to mention that the topic of this work suits the field of analytical chemistry. No objections about that. And finally, I wanted to say that the thesis by Alexander Kononov, titled The Development of a Method for Lung Cancer Diagnosis based on online analysis of exhaled breath using metal oxide gas-sensitive sensors meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University, issued November 19, 2021. And Mr. Kononov deserves the academic degree of Candidate of Sciences in Chemistry in Specialization 142, Analytical Chemistry. And Articles 9 and 11 of the above-mentioned order are not violated. Thank you, Professor. Alexander, you can answer the questions. Thank you very much, Professor, for the questions. The first question. Preliminary in the literature data, we started a section on informative characteristics extraction from the signal of semiconductor sensor. And in a range of works, we compared classification accuracies during different types of extraction of signal. An integral form provided better quality compared to analytical signal based on maximum value of electric conductivity. So difference of electric conductivity or relative change in electric conductivity. So these are the classical forms obtained during the compound analysis. And also due to short time of sampling, the integral form of analytical signal proved to be more productive than classical form. And then as for the rock curve and calculation of areas below, we use it for several goals. If we won't reach the necessary levels of specificity and sensitivity, considering the standard threshold of 0.5, we would implement the search of optimal threshold of classification to achieve the levels. And in this work, we did not require it. We managed to cope with the initial threshold, so we did not require variation. And similarly, as in case of calculation and representation of results in the works of major diagnostic indicators, it is recommended to show the rock curve as well. And as for the third question, standardization approach. In the context of transfer of gradation dependencies for multi-sensor systems, the standardization of response is the most logical choice. And here we can unite samples measured at different multi-sensor systems into a unified base, thus increasing the number of samples and improving the reliability of the forecasting model. Thank you. The only thing that I wanted to add is that the first question, it goes in line with the question of Oleg Vasilievich. Why do you dope? And in fact, your sensors are semiconductor sensors, aren't they? And the width of the prohibited zone plays a role. And with doping, you could shift this width of prohibited zone, and thus you could change the characteristics of these sensors. And that's it. Thank you. Okay, so you are satisfied with the answers? Yes. Okay, now I would like to give the floor to Professor Shapashnik. So, distinguished colleagues, Ludmila, first of all, I would like to thank you for the opportunity to participate in the work of the board. That's quite an honor, and it's very interesting to participate in the discussion of the work of Alexander Kononov, because I worked with medical diagnosis as well, using INOs based on semiconductor metal oxide sensors. So I used this equipment in hospitals. I worked with patients, and along with that, we analyzed samples of exhaled breath in patients with lung cancer using chromate mass spectrometer. So I know how complex it is, therefore I can assess fully the results of work of Alexander. And in the title, INOs, we mentioned the correspondence between an analytical device and the nose of human being or animal. And by the way, this approach has certain advantages, but its application gives us certain complex problems. So what are the advantages here? INOs allows us to use a relatively simple sensor system, and it allows us to transfer a lot of information on the object from sensor to process them into a laconic image. And though this image is based on objective data, it is not reduced to this data only. So the instrument creates something individual, like, the conscience of a human being. And during the presentation, we've seen the images of the studied objects as spots, as points in the space. And these images show us something that was mentioned in the work of Thomas Nigel, what it means to be a bat. He used this term as a subjective representation of the object. And it is hard to understand how bats perceive objects, because it has a different sensory system. And it's hard to understand a different animal, and it's hard to give complete information to the INOs. And as it was mentioned, the sensors are not identical. And basically, that is the problem of INOs. Based on the sensory system, it is not enough to get an image of a healthy person's breath and a sick person's breath, though it is a complex problem, and Alexander managed to cope with it. This accumulated information should not be lost. Like, the loss of an accumulated experience of a human being when the human being dies. And David Chalmers called it a conscience problem. How quality is formed, how can we transfer this image? And this problem was resolved. And that's, by the way, the achievement of not only Alexander, but also the achievement of the Vlasov School. And we all remember Professor Vlasov as an outstanding scientist and as an outstanding human being. And I'm glad to see that his school is developing. And regardless of the fact that this thesis should be marked as a thesis of very high quality, I still have certain comments. In the work, you lack data of characterization of gas-sensitive materials. It would be nice to include X-ray phase analysis and electron microscopy and references to the appropriate data. Second point, in the work, you use sensors with 3 types of gas-sensitive materials. And an increase of set of gas-sensitive materials would simplify the goal. And the third question was previously asked. In the literature review, you provide a classical example of analytical system of analytical signal acquisition as relative electric conductivity, and you use an integral form of analytical signal, and the advantage was not fully described in the work. But these criticisms do not compromise the overall high value of the work, and the thesis by Alexander Kononov titled The Development of a Method for Lung Cancer Diagnosis based on online analysis of exhaled breath using metal oxide gas-sensitive sensors meets the requirements established by the order on the procedure of granting academic degrees at St. Petersburg State University. And Mr. Kononov deserves the academic degree of Candidate of Sciences in Chemistry in Specialization 142, Analytical Chemistry. And Articles 9 and 11 of the above-mentioned order are not violated. Thank you, Alexei. Alexander, you can answer. Yes, thank you very much, Professor, for the questions. The first question on characterization of gas-sensitive materials. Unfortunately, I don't have access to this data, but the prototype of sensors was Sensors 2000. And they're used for low molecular compounds. The second question on gas-sensitive materials. Yes, I agree with you. In order to improve the information quality, we considered the differences in temperature of the heater and the number of different materials that could be obtained that would allow us to obtain more information of the system. So should be considered. Therefore, we plan to have the replacement of these sensors, and we also analyzed vanadium sensors, but unfortunately right now it didn't give us the close characteristic from the point of view of stability of the signal and shift to the basic line, and that's very important if we talk about the time of analysis. And as for the third question on the integral form, there are two reasons. The first reason was that based on the studied data, and that's not the information taken from one work, so that was a review that demonstrated that the integral form has more information capacity, and the accuracy in dividing VOS is quite high, and it reaches 100%. Thank you. Alexei, are you satisfied with the answers? Yes? Thank you. The only thing that I wanted to mention is that integral form is not used. I understood why you used it. Maybe you lacked the exhaled breath, but still I understand why you chose it. Okay. So, Larissa, now it's your turn. So, please, your opinion and your conclusion. Thank you so much. Thank you very much for the invitation to participate in the work of the board, and I would like to thank Alexander for the presentation and for the fascinating work that I was pleased to read. And to my mind, this work is dedicated to a very relevant problem of analytical chemistry. And at that, it uses chemical sensors. And that is the field that is very interesting to me. And the application of chemical metal oxide sensors in this work is aimed at the development and testing of a new diagnosis method for lung cancer. Sure enough, the novelty and the practical value of this work and the problems were studied well and described as well. The work is quite accurate, though it has certain inaccuracies and misprints, and some of them were described in the comments because they really sometimes prevented the correct understanding. And I wanted to mention a lot of studies that the author conducted, and he also obtained impressive results that allowed us to see the opportunity for dynamic study of patients with a limited time of analysis. And all these measurements are backed with significant value of mathematical calculations. So this work unites a lot of tests, chemometric tests conducted with a consideration of all the chemometric analysis requirements, and this allowed to ensure high accuracy prediction. And this was done both for test and for training sets. So training sets were divided. And in this regard, I wanted to mention this huge work that the author conducted. And to my mind, one of the most significant achievements and the most impressive achievements is the opportunity to transfer graduation dependencies demonstrated by the author. Why? Because, as it was already mentioned by Alexei, the measurement using multi-sensor system like INOS, that's the work that is conducted several times, and it is quite complex, and it would be really a pity to use the data accumulated during all these numerous measurements at hospitals, for different patients, for healthy volunteers. Therefore, for similar sets of sensors, data may differ. Therefore, the shift of gradation dependency is a huge step forward that allows to develop methodology that has a high forecasting value and potential for non-invasive diagnosis of cancer diseases with the use of metal oxide sensors. To my mind, the author managed to cope with all the problems, and the results were tested at Russian and international conferences, and the results were also published in high-ranking journals. And as for the work itself, I've mentioned 6 remarks. The first 2 are associated with a literature review. I won't read them. I believe the author could have described different types of sensors that you mentioned in the literature review, as they are used in multi-sensor systems like electronic nodes, that's mass-sensitive sensors, and optic sensors as well. And I understand that the author worked with different type of sensors, but if he mentioned them in his work, it would be expedient to give at least a short description of the principles of functioning of the sensors that you mentioned. And Article 3 And here I read it. Section 1.3.2.6, dedicated to the theoretical description of the principle of work of semiconductor metal oxide sensors used in the work, also seems quite incomplete. There's lack of schematic image of the sensor, including the detailed description of the response of the sensor to different volatile compounds. We've seen a slide in the presentation, so I've mentioned that, but this description could improve the overall quality of work. And in section 2.1 and in table 5, the author gives the description of metal oxide sensors. However, the substantiation of choice is not provided. And this was mentioned by colleagues today. Does it mean that the author did not work on the development of metal oxide sensors and on the choice of optimal set of sensors, and just used the previously tested set of sensors? So we've already got to the answer to this question. And the thesis is mostly dedicated to the application of mathematical analysis method of multidimensional data, and it contains a lot of mathematical expressions and equations, and many of the parameters and operators of these equations are not described and deciphered in the text. And I, for example, as a chemist, had certain problems in reading this work and in the perception of this work. And Article 5 in Chapter 3 in Table 18, that demonstrates the error matrices for the breakdown. The number of samples is varying. I believe that the number of samples should be the same, and as for the classified samples, summary does not comply with the number of samples in the true class. And the last remark, in Chapter 3 of the thesis on page 74, you mentioned the sensor S4 is the most important for the classification of analysis of coupled graphs of scattering, and there you quoted figure 14. I believe that's a misprint because it should describe figure 13, and you've also quoted figure 14 incorrectly. It should be figure 17. So these inaccuracies really give us some misunderstanding in the interpretation of the results. And this really complicate the understanding of the work. However, these criticisms do not compromise the overall high quality of this work. Therefore, I believe that the work of Alexander Kononov, titled The Development of a Method for Lung Cancer Diagnosis based on the online analysis of exhaled breath using metal oxide gas-sensitive sensors, meets the requirements of the orders of November 19, 2021 on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Kononov deserves the academic degree of Candidate of Sciences in Chemistry in Specialization 142, Analytical Chemistry. And also Articles 9 and 11 of the above-mentioned order are not violated. Thank you, Larissa. Alexander, please, you can answer. Professor, thank you so much for the comments. As for the first two questions regarding the description of type of sensors and their principles of work, I would like to answer the following thing. I agree with the fact that I could have provided a more detailed description for this type of sensors. because these sensors are quite frequently used in such works in comparative studies to differentiate different groups of controls. And I would also like to mention here that in the work, during the description of types of sensors, I had a goal to describe those for which we already had certain applicable sensitivity and specificity indicators, so that it would allow us to compare them between themselves. As for the third question, I agree that the description of the principle of work was provided during the presentation. It was considered in the context of application of in this work, and in my presentation I tried to reflect it all and to describe the general principle of response for different types of gas. Maybe I should have added it to the text of the thesis. And now a question, or the fourth question. A fourth comment. Indeed, in both parts, I used several methods for the analysis of multidimensional data. And during the description of methods that I used, I did not want to use just references. Therefore, I tried to describe the principles better. That brought a lot of formulas and parameters, and I should have described them better. As for the fifth comment on divergence in the matrices of errors, in the thesis, indeed, I had a misprint for the classifiers matrices. So that was done for Kononov method. So I had an error here, and the number of false, positive, and negative results. So that's because I transferred this data. And also question 6, indeed, that's also a misprint in both cases. I should have referred to figure 17. That's it. Larissa, do you agree with the answers? Yes, I'm satisfied with the answers. Well, and I'll try to sum up. A lot was mentioned already, so I'll give just the basic points, and I'll ask my questions and give the conclusion. And the goal was to develop methodology for online analysis of exhaled breath using the system of gas-sensitive metal oxide sensors to diagnose lung cancer. The relevance is obvious, regardless of numerous publications in this field still. The question on diagnosis at early stage is open. And we also need an online method, a simple method, non-invasive one, sufficiently cheap. And I should mention that the author provided a direct online analysis without additional sample preparation. And I will agree with one of the opponents that the most important part on the experiment, on the study of possibility to transfer graduation dependency between two multi-sensor systems is important. And as a result, we see the need to standardize the response. The most important thing in scientific novelty is the implemented online scheme for the analysis of samples based on gas-sensitive sensors without preliminary sample preparation. And also this method ensures a high specificity and sensitivity. as well as the predictability of result. So these characteristics are better than in the materials that were already published on the issue, and also the practical value is quite obvious. And as for the text of the thesis, I had several questions, and some of them were already mentioned by colleagues. So what was the main principle of standardization of sampling? How long did the sensors preserve their work characteristics during exploitation? The author mentioned that during visualization of data in two-dimensional space, you constructed 3 matrices for each temperature regime with scattering, but intergroup division was observed for 1 temperature regime. How can it be explained? Fourth question, did you manage to eliminate the memory effect completely? The fact explained by this option of volatile organic compounds. Didn't you see any losses of analytes? And the question that Oleg had. You state that all the measurements were conducted in rooms with high level of humidity, and you mentioned this level, 60%. And how did you ensure the reproducibility of these conditions? And I can agree with opponents who said today that these questions do not compromise the overall high value of this work. This work was tested broadly, and the author published 3 articles in journals, Index and Web of Science and Scopus. And as a conclusion, as I'm the last to deliver my review, I want to say that the thesis by Alexander Kononov is a qualification work. It has solutions to an important medical analytical problem dedicated to the development of methodology of online analysis of exhaled breath, exhaled air using gas-sensitive metal oxide sensors, and the thesis by Alexander Kononov on the topic of the development of a method for lung cancer diagnosis based on the online analysis of exhaled breath using metal oxide gas-sensitive sensors meets the requirements of the order as of November 19th, 2021. On the procedure of granting academic degrees at St. Petersburg State University. And Mr. Kononov deserves the academic degree of Candidate of Sciences in Chemistry in specialization 142, Analytical Chemistry. In Articles 9 and 11 of the above-mentioned order are not violated. So please, you can answer. Lyudmila Alexeyevna, thank you so much for the questions. The first question was on standardization of sampling, and in this work, the standardization of sampling was based on the fixed length and speed of breath technique, calm breath, and procedure before the analysis. That's cleaning up of the oral cavity 10 minutes before the analysis, and abstaining from smoking and eating for 1 hour. As for the work characteristics of sensors, in order to improve the stability of response, we annealed the sensors. And the stability was assessed by measurement of single component gas mixture of propanol, and maximum deviation did not exceed 20%. The third question was about the division for sensor temperature regimes. So considering the signal was not selective and we had no additional data measured, that would allow us to define the compounds. It's hard to provide an insight, therefore I'll give just a general answer. We can presume that at this temperature regime, T1, sensors have sensitivity to those compounds, the concentration of which can impact the state, can be influenced by the state of health. And as for the fourth question, I can say yes. The signal of the sensor gets back to the basic line for the relevant time when the speed of air supply is high. As for the fifth question, the reproducibility was ensured for relative humidity because we had an opportunity to master the basic settings. Okay, thank you so much. Now I want to ask the colleagues if everyone is satisfied with the answers of Alexander. Yes, I am. Yes, me too. Larissa, Boris, thank you. We don't have a lot of people here in the audience, but still, I need to ask this question. Speeches of those who are in the room who wanted to comment on something? No? Another question. As we organize a broadcast during the board session, I need to ask a question if we had any additional questions. None. Okay. Now we shift to the next item on our agenda. We're going to listen to the thesis supervisor, Alexander Ganeev. Please, you have the floor. Thank you. Well, Alexander, I won't praise him too much, but I'll say that he's an A student with a very good understanding. And his most significant achievement is that he did not drop from the PhD course when he got this topic of study, because many people were afraid of it. So here are two blocks, and quite serious blocks of study, and they're very labor-intensive. The first block, medical studies, and all these measurements that he conducted was not processed and included. For example, the choice of healthy people was more complicated than the choice of patients. Indeed. Therefore, the first block of measurements has failed because we lacked the health certificate of healthy people. Therefore, healthy people were chosen from medical institutions that could confirm lack of this disease, the absence of this disease in the tested person. And this certainly increased the volume of conducted study and the time that Alexander had to spend on that. And what surprised me most in his work is the speed. He mastered chemometric processing methods. That's his personal achievement and his perseverance. Yeah. And once again, part of materials was not included as well. And finally, we got a surprising figure that proves that inos, well, initially we had a set of sensors that we could choose from. Something is better, something is worse, and so on. And out of all of that, we managed to create a methodology, to devise a methodology that shows very high efficiency. And I want to emphasize that the best samples of ionoses, the data that Sasha got, so they are at the same level. And if we compare this method with other methods of analysis, this one is even better. And in conclusion, I would like to say that indeed Alexander, from my point of view, really deserves the degree of candidate of sciences in chemistry, because his work demonstrated it fully, that he's ready to continue his academic studies, and I hope that we will continue working together with him. Thank you, Alexander. Well, should I formally read this part? This achievement? No. No, there's no need for that. We heard that you are quite satisfied for having this PhD student and you want to continue cooperation with him, and I want to ask other members of the board. You know, we seriously discussed this work, and that's quite an informal variant. And now I would like to ask colleagues if anyone is willing to comment on anything once again. No one. Yeah, may I? I wanted to say that, once again, as I've already mentioned it in my report, that is a continuation of those works on electronic language, this ENOS, and here our university is one of the leaders. Yes, one of the leaders indeed. I agree with that. Therefore, it's quite nice. Okay. I still need to ask a question. Yeah, sure. I need to ask a question to the applicant for the degree, and I want to ask everyone who participated. Yeah, I saw a hand was raised. Yeah, as we have a free discussion right now that can dwell upon the issues that were previously mentioned. Ludmila, you asked Alexander how he managed to cope with the problem without concentration. And that's an important problem because I worked on it using mass spectrometer. And good contemporary chromatin mass spectrometer demonstrated that the difference in exhaled breath of a healthy and sick person is not that significant within the margin of detection, you know. And we concluded that we really need a pre-concentrator, and I worked with pre-concentrator. I have such an experience, but in this case another problem arises from this range, from these dozens of biomarkers. And these biomarkers, you know, practically they don't work in a yes or no system. That's mostly a choice of concentration. Somewhere it's higher, somewhere it's lower. Many of them are not stable, and in concentration they will break down. So that's a real problem. So I just wanted to get back to the question that I previously mentioned. Thank you, Alexei. I did not ask this question by chance because, you know, I understand the problems that may emerge during concentration, considering the range of analytes. Larissa, I believe you raised your hand as well. Yes, I wanted to comment. I wanted to add up a topic for further studies. I understand that the thesis supervisor has certain plans for the future. I wanted to offer you to study hybrid systems based on different transduction methods. So you studied metal oxide sensors for the analysis of gas mixtures. And in the scientific group I work with at Tonbagata, we also conduct one of the projects on the application of INOs based on quartz microweight. That's piezo-sensitive sensor. And many projects are conducted on the analysis of exhaled breath and diagnosis of different diseases. And that is why it would be interesting to try to use your system of online analysis together with our developments. Therefore, I wish you further continuation of your studies, and I offer to visit our lab as well. Thank you, Larissa. And once again, I need to ask a very important question on our procedure. So, I would like to ask the members of the board and the applicant for the degree, and I need to solicit an answer from all of you. Does anyone have any remarks or questions on the procedure of the session? Maybe the ones associated with remote access. Oleg? No? No? No questions? No questions? Okay. And Alexander? No questions. Okay. In this case, we shift to the next item in our agenda, the vote. Distinguished colleagues, before we start voting, we have an opportunity to announce a technical break to discuss the results without broadcasting. How do you think? Do we need such a close discussion? No? No? No need for that? Okay. Larissa, Alexei? Okay. In this case, dear colleagues, we continue the session. And it's 3 minutes to 4. So we all hear each other. The broadcast is on. And now we are approaching the final minutes of the session. Once again, I need to check whether we all hear and see each other. Yes, the answer is yes. I saw that colleagues noted. Okay. Therefore, I raised the question on the award of the academic degree of candidate of sciences in chemistry in specialization 1-4 to analytical chemistry to Alexander Kononov. So now we're going to organize a poll. And I would like to emphasize that by voting for the award of the academic degree, each member of the board agrees that Article 11 of the order is not violated by the candidate. And let me quote it. In the thesis, the applicant for the academic degree is obliged to cite the author and or the source of materials or individual results borrowed. Using the results obtained by the applicant personally or in co-authorship, the applicant for the degree is obliged to note this circumstance in the thesis. And let me remind you that the decision of the Dissertation Board on conferring the academic degree is positive provided more than 50% of the board members voted in favor, and not fewer than 3 people. That's in conformity with Article 23 of the order. So, Professor Ryttenkov. Well, I believe Alexander deserves the degree of candidate of sciences. Thank you. Professor Simonov. I also support this work and believe Alexander deserves the degree. Thank you. Professor Shaposhnik. Yes, I also vote for the award of the academic degree in specialization in analytical chemistry. Okay, thank you. And Larissa, Professor Lvova. Yes, I agree with colleagues, and I believe that Alexander Kononov deserves the academic degree of Candidate of Sciences in Chemistry and specialization in analytical chemistry. And okay, now it's my turn. I, Lyudmila Kartsova, believe that Alexander Kononov deserves the academic degree of Candidate of Sciences in Chemistry in specialization in analytical chemistry. Now, we need to calculate the votes. Distinguished members of the board, I would like to announce that out of the 5 members of the board who participated in the vote, 5 voted in favor. No one voted against. Against it, and no one abstained from the vote. Thus, we decide to award the academic degree of Candidate of Sciences in Chemistry in specialization 142 analytical chemistry to Alexander Kononov. And that's it. Now we give the floor for the finalizing remarks to Alexander. Yes, thank you so much. In the end, I wanted to express my gratitude, first of all, to my thesis supervisor, Professor Ganeev, for his support during all these years, for the moral support, for the opportunity to stay independent at some points. And I would also like to thank Igor Eduardovich for his help in writing articles for frequent discussions of gas analysis, and I would like to thank all my friends and relatives and my spouse for support, and I would like to thank all the members of the board for the time that you spent on reading this work. And I believe everyone agrees with me that on behalf of all the members of the board, we would like to congratulate Alexander. We wish you to have these results as a start of work. And they say that those who do not sail never enjoy a wind. So we wish you this wind that will bring you forward, and we congratulate you. So, dear colleagues, let's give a hand to Alexander. And in his biography, he now has a new and important date, and I, as the chair of this board, would like to announce that I thereby close our board session, and I'd like to thank everyone, and I ask you to switch off the broadcast.